Good morning, friends. Today we are going to see about the number systems in digital logic circuits. Number system. So, number system. So, if you see the number systems in digital logic circuits, we are going to see about four different types of number systems. The first number system is nothing but decimal number system, decimal. The second one is binary number system. Third one is octal number system, and the fourth one is hexadecimal number system. Hexadecimal number system. So these are the four different types of number systems we are going to study in digital logic circuits. So if you see this first decimal number system. So in decimal number system, the base value of a decimal number system is 10. So the base is 10 here. The base can also be called as radix. It can also be called as radix. So the base of this number system is 10. Here, if since this it is having 10, it is having totally 10 numbers. That's why it is having the base value of 10. So what are the numbers that has been represented in a decimal number system are 0 to 9. So total 10 numbers we have. That's why it is having the base value as 10. So these are the 10 numbers that a decimal number system has, 0 to 9. So the second number system is nothing but a binary number system. So the binary number system has only two numbers. So two numbers. What are the two numbers it has is one either 0 and 1. So these are the two numbers that a binary number system has. So totally it has only two numbers. What are the two numbers it has are 0 and 1. So you see here the base value or the radix of this binary number system is nothing but 2. So if you are representing a number by base 2 means we can understand that it comes under binary number system. And the third one is octal number system. So octal. So octal means it represents a number 8. So this number system has totally 8 numbers, ranges from 0 to 7. So totally it has 8 numbers. Numbers ranges are from 0 to 7. So the base value of this number system, is nothing but 8. And the hexadecimal number system. So this is the fourth last number system that we are going to study. So this hexadecimal number system has totally, it has 16 numbers. 16 numbers. So that is, if you represent in decimal, we can tell it is 0 to 15. So decimal number system means if you are representing these 16 numbers in as a decimal number, it has 0, it ranges from 0 to 15. So actually how we will be representing this hexadecimal number means decimal number has totally 0 to 9 numbers, and after that it will be represented as the alphabet values of A to F. So here 0 to 9 total 10 numbers, and the remaining 16 numbers are represented from A to F. So if you see here in this number system, this A value we are having A, B, C, D, E as well as F. So what is this value? If you see here means the decimal value, the equivalent decimal value for this alphabets is nothing but A represent 10, B 11, C 12, D 13, E 14 and F represent 15. So totally das ranges from 0 to 15 as a decimal value. That's why we are represented here from 0 to 15. So totally it has 16 numbers. So ranges from 0 to 15 in decimal. So how this decimal hexadecimal values are represented here are from 0 to 9 total 10 numbers, and after that 16 numbers are represented as the alphabetical value from A to F. The equivalent decimal value for A to F are 10, 11, 12, 13, 14 and 15. So since it has totally 16 numbers, the base value for this number system is 16. So this is the base value for this type of number system. So Now, so we all understood what is the different number systems we asked, or what are the different number systems in digital logic circuits. So totally four now different number systems we have studied. One is decimal, next binary, third octal, and the fourth one is hexadecimal number system. So next we are going to see how to represent a decimal number, how to convert. So how to convert a decimal number as different types of number systems. So decimal can be represented as a binary number or octal or hexadecimal number. So how can we represent all these numbers, we are going to see next. Okay. So now we are going to take the binary numbers or decimal number value. So decimal value, how to represent this decimal value in terms of binary, we shall see first. So let us take one example for this representation. So if you want to represent any a decimal number to any other different numbers. So for example, if you are converting a decimal number, if you are converting a decimal number to a binary number, binary, or if you are representing this decimal as a octal number, or if you are representing this decimal as a hexadecimal number, so what you have to do here means we have to follow the common procedure. So what is the first step that is used here is you have to divide the decimal number by the base value. So if you want to convert this as a, so this is the first step. So we need to divide the decimal number by the corresponding radix value or the base value. So if you want to convert a decimal number to an octal number means what is the base value of this octal? It is 8. So we need to divide this decimal number by the base value of 8. Similarly, if you want to convert it to binary means you have to divide it by 2. If we want to convert this to a hexadecimal means we need to divide it by 16. So this is the common rule that is followed here. So for example, if you are taking one number, if you are taking a number so I'm taking a number which I have to divide this by one. So I'm taking a decimal number as 37. So if you want to convert this 37, so I'm having a decimal number 37. So I need to convert this. This is a base 10 number. So now I'm going to convert this as a decimal number. Sorry, this as a binary number. Binary number. So what you have to do here means we need to convert for converting a decimal number to any other number system. What you have to do means we need to divide that corresponding decimal number with the base value of the number to be get converted. So we are going to convert it to binary. So the base value of this is 2. So we are going to divide this by 2. So 3 means 1s are 2. Remainder is 1, so 17 it will become, so 8 2s are 16. So we are having one remainder, so you have to write like this. So similarly, you are going to divide it by 2 again, 9 2s are 18, so there is no remainder, so 0. Again divided by 2, so we will be getting 4 2s are 8, we are having 1 as the remainder one. Again divided by 2, so we will be getting 2, so remainder is 0. Again, if you have to divide it by 2, you will be getting the remainder as 1, sorry. 1 in 1 2s are 2, so 1 and the remainder here is 0. So you have to write the number from top to bottom. So you can represent this as 1 0 0 1 0 1. So this is the corresponding binary value for the decimal number for the decimal number 37. So like this we need to convert into any number. So if you want to convert this same 37 to octal number means octal number. So binary we have converted. Again, if you want to convert this as an octal number means what you have to do again. So you have to divide this 37 with respect to the binary values or base value of octal is 8. So if you are dividing it by 8 means 8 4s are 32 you will be getting. So 32 reminder here is 5. 30. So we can't divide again. So you can write this number as 45. So here the corresponding octal value for 37 is 45 to the base 8. Similarly, if you want to convert this as a hexadecimal number means hexadecimal number. So if you want to convert this as a hexadecimal number means what you have to do? You have to divide the number with the base value of the hexadecimal. So what is the base value for hexadecimal? It is 16. So 37 divided by 16, 15. 16 twos are 32. So 16 twos are 32 will be getting remainder 5. So we'll be getting the number as 25. So 25 is the hexadecimal value corresponding to the given decimal number 37. So here it is a base 16 number. So similarly, so you have taken one decimal number. So we have converted the corresponding decimal number to a binary number, octal number as well as hexadecimal number. So this is the value for binary and this is the value for octal and this is the value for hexadecimal. So like this we can perform the operation if you want to convert any decimal number to any other corresponding number system. So if you are taking, so this is a whole number we have taken. So if you want to convert the value with respect to a decimal value means there is an integer number, not only a whole number if you are taking a decimal value means what you have to do we can see. So if it is a whole number, what we have done here means we have divided it by the corresponding base value. And if it comes with after point number, if you are having a number means what you have to do means we have to multiply that with the base value. So let us consider the value as 37.35. .35 I am taking. This is a decimal number. So how to convert we shall see now. So you know that the corresponding 37 has the binary value of 100101. So I'm going to erase now. guys, so we have taken the binary number as or decimal number as 37.35. So this is a hexadecimal number. So sorry, it is a decimal number. So we need to convert this as a binary number. So 5 binary number. So 37 is a whole number. This number has the value corresponding to 100,101 that we have already seen. Now we are having a decimal number which is equivalent to 0.35. So what you have to do here means we need to multiply this with the base value of the number to be get converted. So it is a binary number. So we need to multiply it by 2. So if we multiply this value with 2 means we'll be getting 5 2s are 10, 0, 1 remainder, 3 2s are 6, so it is 7. So you're getting the value as 0.370 if you are multiplying it with 2. So from this we need to take the whole number what we have got. The whole number we have got here is 0. So we need to consider only 0 here. Again we need to multiply this value with 0.70 with the base value 2. So we'll be getting the value as 2 zeros are 0, 7 2s are 14, so 4, 1 you'll be getting. So after 2 you'll be having the decimal, so place the decimal here. So what is the whole number we have got here is 1. So how many times we need to go for this multiplication means we need to, how many numbers we are having after decimal point here, only 2 numbers we have. So until 2 we have to go for 2 multiplication operation. So what you have to do here means we are going to multiply the given decimal value with respect to the binary values base value, that is 2. We have got the first multiplication value as 0.70. From this we need to take only the whole number as the answer. So here the whole number is 0, and after the second multiplication should be carried out only with that of the decimal value we have got here. So here it is 0.70. So only with the 0.70 we are going to multiply. We should not consider this 0. This is the whole number we should not consider. Only we have to take the decimal value for multiplication. So again we are doing the multiplication. We have got the answer as 1.40. So here the integer value you have got here is 1. So we can take the answer as 1 here. So from that, if you see the whole number division, we have divided it by 2 and we have returned the answer from bottom to top. Here we have to write the answer from top to bottom. So it is, this value is the whole number value dot 0 1 is the value for the given decimal value. So like this you have to write and put the base value as 0. So this is the thing you have to remember here. So this is the thing, like this only we have to do the operation. So the answer here is 100,100,101, that is the whole number value dot 1. For 0.35 it is 0.01. So this is the answer for the given decimal number which has been converted to a binary value. Similarly, if we want to convert to octal or hexadecimal means we have to multiply the given decimal number with respect to the base value of the corresponding number system to be get converted. So like this we need to proceed. So next we can see how to convert a given binary number to an octal value. So given binary number to an octal value. So how to convert this as a binary octal number? So for that I am taking one example for given binary number. One binary number I am going to consider. So I'm going to consider one binary number. How to convert that binary number to the corresponding octal number or hexadecimal number we shall see. So we are taking a binary number. So conversion is from binary to any other number system. That is, first we are converting it to an octal number system. So for example, I am taking the value as example. Example problem. So it is an example problem. So I'm taking the binary value as 10101. So we need to convert this as it is a base 2 value. We need to convert it to an octal number. So how to convert this as an octal number means octal, it is having totally 8 numbers, ranges from 0 to 7. So the maximum value for an octal number is nothing but 7. So how many bits are used to represent this number 7 is only 3 bits we need to represent. So 111. So we are considering 8421 format. This is 421. So 4 plus 2 is 6. 6 plus 1 is 1. 6 plus 1 is 7. So totally we are having only 111, which represent the decimal number 7. So how many bits here we are using here is maximum. It requires only 3 bits for representing the maximum value of octal, that is 7. So these only 3 bits we are going to consider. So we are considering this 3-bit value means what you have to do here means for converting a binary number to an octal number, we need to divide the given number, binary number, into 3 bits. So we are having 1 0 1 0 1. So first, starting from the least significant bit. So this is the least significant bit value and this is the most significant bit value. So we need to start from the least significant bit value. We need to divide it into 3 bits. So 1, 2, 3 bits. So you can put one slash. Here you are having only 2 bits. So the third bit we can include it as 0. So now after dividing like this, you have to write the value corresponding value. So here it is 421 format. So here it is 2 and here it is 4 plus 1, that is 5. So what is the number we are having getting here is 25. So the 25 is the corresponding octal number for the given binary number. Similarly, if you want to convert this binary number to a hexadecimal number, what you have to do here means we need to divide, because hexadecimal number, if you see, it has only 16 numbers. 16 numbers means that is the numbers ranges from 0 to 15. So 15, if you consider, we are taken the 8421 format. 8 plus 4 is 12, 12 plus 2 is 14, 14 plus 1 is 15. So if all the bit values are 1, we'll be getting the value as 15. So now if you see here, so how many bits it is used to represent here is totally it requires 4 bit value. So if you want to represent a given binary number to hexadecimal number, what you have to do means we have to split the number by 4 bit values. So you are having 1 0 1 0 1 means from the least, this is the least significant bit value and this is the most significant bit value. So from the least significant bit value, we need to divide it into 4 bits. So 1 2 3 4. So 4 can cancel. And remaining you are having only 1 bit, so previous bit values you can include it as 0. So 0 0 0 1. So if you represent the corresponding number for these bit values means 0 0 0 1 is 1. It is 8421 format, 8421. So it is having only 1. And this if you represent 8421 format, you will be getting the corresponding value as 4 plus 1 is 1. So it is 15. So what is the corresponding value? This is the hexadecimal number. So the corresponding for the given binary number, the corresponding hexadecimal value is 15. So like this only we need to perform. And next we can see how to convert an octal number to a binary number. Octal number to a binary number. So how to convert this one is. So now you can take an octal number. So let us consider the octal number as 345. So how to identify it as 345 is an octal number. So if they have given it as a base 8 means you can directly identify it as an octal number. If they haven't given it as a base 8 number, means how to identify whether it lies in octal group or comes under hexadecimal number group, means how we can identify, means we can see here what is the maximum numbers they have used here. So since they have given here the maximum value is 8, the given number is so octal number to a binary number we are going to see. So octal number here is 3, 4, 5. So here if you see here 3 lies within 0 to 7, 4 lies within 0 to 7 and 5 also lies within 0 to 7. So it is a octal number we can design. So how to convert this octal number to a binary number means nothing but how you have to represent. Each number should be represented as a 3-bit binary value. So what is the value for 3 here is 0, 1, 1 and 4 means 1, 0, 0 and 5 is 1, 0, 1. So the total number we are having here is the corresponding binary number. Similarly, if you want to convert this as a hexadecimal number, hexadecimal. So hexadecimal 3, 4, 5. So each bit should be represented as a 4-bit binary value. So we need to convert this as a octal number first, and after that from the octal number you can convert, this octal number should be represented as a binary value first, and from the binary value we can write the corresponding hexadecimal value. So what is the value for 3 is 0, 1, 1 and 4 is 1, 0, 0, 5 is 1, 0, 1. So now after writing, this is the binary value, this is the binary value. So after writing this we are going to convert it into hexadecimal number. So how to convert this means binary to hexadecimal conversion. So here we have to split it into 4 bits. So this is the first 4 bit. Then after that 1, 2, 3, 4. Again 4 bit. Again all the values you can put as 0. So it is 0. And here it is 1, 1, 1, 0. So 8, 4, 2, 1 format. 1, 1, 1, 0. So here it is 8 plus 4 is 12. 12 plus 2 is 14. 14 means it is represented as binary. It is a, we represent by hexadecimal number 0 to 9 and E to F. F represent 15. So it is E and 0, 1, 0, 1. So 8, 4, 2, 1 format again. 2, 1 format it is 4 and here it is 5. So it is 5. So what is the value you have got here is E5. So this is the corresponding hexadecimal value for the given octal number. Next, any number system to be converted to a decimal number. What you have to do? What is the procedure we need to follow? We shall see. Okay, what is the procedure? We are going to how to convert any number system to a to a decimal value. So if you are having a number, as 77014, it is represented, it is a octal number. We are going to convert this octal number as a decimal value. So if you want to convert this octal number as a decimal value, means what is the procedure we have to follow here? Means if you want to convert any number system to a decimal number system, means what is the step we have to follow here is you have to multiply each and every digit of this given octal number with a base value to the power of the place value of the number. Okay, so if you are converting, this means this number they have given. So what you have to do means you have to take this 4 first. 4 multiplied by, what is the base value here? It is 8. So 8 to the power. What is the digit value here? Place value, it is 0. This is 1. This is 2. And this is 3. So it is represented as a to the power 0. So what is the value? You have to write it here. So a to the power 0 means it is 1, so it is 4. Likewise, the second digit you have to take, it is 1. So 1 multiplied by a to the power, the place value here is 1. So a to the power 1 is 8. So here 1 into 8 is 8. Similarly, if you see here, the third number is 0 multiplied by a to the power, the place value here is 2. So any number multiplied with 0 will get the value as 0, 1. And next the number is 7 multiplied by a to the power 3. The place value here is 3, so 8 multiplied by 3. So a to the power 3 multiplied by 7, you will be getting 3, 5, 8, 4. 3, 5, 8, 4. So if you add this number, all these numbers will be getting the value as 3, 5, 9, 6. So this is the corresponding decimal number for the given octal number. Similarly, if you want to convert it into a binary number, if you want to convert a binary number to decimal number, you have to follow the same procedure. So in the place of a to the power 0, a to the power 1, a to the power 2, a to the power 3, you have to take the value as 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Like that it will be going on. Similarly, if you want to convert a hexadecimal to decimal means also you have to multiply it with the base value of hexadecimal, that is 16 to the power 0, 16 to the power 1, like that. So, so friends, we have seen the different number systems that are used in digital logic circuits and how to convert a given number system to the corresponding other number system also we have seen. The next topic we shall see it in the next class. Thank you, students.